Hi everyone, welcome to this talk about scaling CloudStack. So let's get started. A little bit about me. I don't think anything new added in here since last year, just this little bundle of joy in our life. So yeah, other than that, everything is same. So this interesting topic, scaling CloudStack. We have been hearing in the morning CloudStack is scalable and companies are adopting it because they can easily scale CloudStack. But early this year, a customer of ours came at Blue and asked how many hypervisor hosts CloudStack can support or how many virtual machines it can easily deploy or manage. Similarly, other resources. So, in short, we were not having a clear answer at that time. Maybe some of you can answer that. Like, you are the CloudStack users, so how many hosts, maximum number of hosts you are running in your installation, or you have seen in any installation? Anyone? Okay, so if no answers, I think uh, many of our customers are already running CloudStack with over 5,000 hypervisor hosts, maybe 10,000 in some cases, as Rohit mentioned. So it's already kind of very scalable in that sense. Uh, it can work with many thousands of VMs and all the other resources. But we have been talking about cloud repatriation and competing with hyperscalers. So this talk and this project was all about taking it to the next level and identify the limits that CloudSync can go while handling those hosts, those networks, those VMs. So we started with uh, seeing how currently we scale with CloudStack. Rohit briefly mentioned this cell model. So in this, there can be multiple CloudStack installations. Each could be running 5 to 10,000 hosts. We are saying 5 to 10,000 hosts because we have seen those with our customers' production environment. It may handle more than that, but let's assume there are 5,000 hosts in one installation. And operator can run multiple of those installation and deploy a overlay API layer on that and try to work with those installation. But challenge here is inter-cell communication. Like how do they communicate when one installation wants to talk to other? What if one installation goes down? What happens to those 5,000 hosts? Where do they connect? So although this cell model is highly scalable in terms of horizontal scaling, but then it has its own challenges. So we thought, let's scale a single installation. Uh, with some discussions with the customer we were working with, we thought let's scale to 10x. If CloudStack can do 10,000 hosts right now, we will try to find those limits and see if it can go to 100,000 hosts. Now, to start with this project, the challenge was how to deploy or access that kind of scale. How to add those 100,000 hosts in a CloudStack installation. Should this be a simulator-based environment, which can mimic all the operations that CloudStack has? Or could it be something else? Like KVM runs on with connected agents. So how to simulate those? Obviously, we don't have access to unlimited hardware and simply deploy 100,000 KVM hosts and add that to CloudStack installation. So how to bring about those hosts? Uh, then the other challenge was how to identify those bottlenecks. What should be our testing criteria? How should we benchmark different operations in CloudStack so we can say in a simple way that, yeah, this many hosts can be supported. These are the number of VMs it can easily manage. So these were a couple of challenges we had. Uh, I will later talk about how we tried to find answers for these. So let's see what bottlenecks we found. For now, let's assume we found some solutions for the problems I said, like how to add those 100,000 hosts or what type of environment to use. We started with the simulator environment and then used a number of tools, like probably the most useful one was JProfiler to find out all those CPU hotspots or database hotspots. We use IntelliJ or any IDE for debugging whenever we found some operation was taking longer time or there were failures. Finding out slow database queries with MySQL Workbench or command line. Then we recently also worked on a nifty tool called CS Bench, which can help benchmark different CloudStack operations. So with the help of these tools, we found couple of these bottlenecks, like we saw when we scaled hosts to, let's say, we deployed 50,000 simulator hosts and tried to do concurrent request. Database was showing bottlenecks. There were concurrency issues, like if 100 accounts were simultaneously trying to deploy VM, we found there were resource allocation issues. It was failing sometimes with host not found, or there were some, like if an account is already breaching its limit, it was deploying VMs even then, because it is trying to do concurrent operations. Then there were issues with fault tolerance, like once there is some issue, CloudStack couldn't recover from that error. Like even now it happens, like if you deploy a VM and it fails, so it doesn't do anything with that VM. It leaves it in error state. So things like that. Then with the agent communication, because I mentioned, we also thought of simulating how we can simulate connected agents paradigm, like how, because KVM runs on the TCP IP connection with management server. So how to simulate that? We kind of simulated that. I will talk about that. But we found there were issues with that communication as well. When you scale that connection to a limit of 50,000 or 100,000, things start to fail, like connection gets slow, things like that. And then there were some other issues. So briefly going into these issues. Firstly, simple one, database. As the number grew, we faced like queries were getting slow or API responses were getting delayed. So initial thought was there were locks happening in different code structure of CloudStack, and that might be creating issue, or the centralized database was causing the problem. We tried to do a POC on a distributed database with a locking service using Hazelcast, but it didn't yield any performance gain. Like things were similar to what it was before. So we went ahead. We then tried to benchmark how many queries or connections CloudStack is trying to create at a scale. When 50,000 hosts are added and we are trying to deploy 100 VMs in parallel, how many requests it is making, how many connections it is trying to create. So we found out it is not much. Like in this image, you can see there are only 118 connections, because we use a connection pooling library which reuses a connection to database, so it wasn't much. Although there's a lot of select query happening, there are not a huge number of updates and deletes. But we eventually found out the issue isn't the database itself, because MySQL can scale, so it is something else. It is how we have structured our schema layer in the cloud stack. We use some old structure. We were missing keys or indexes for different tables, which was causing slow queries. Then there were repetitive queries, like in an estimate, we found out even while deploying a VM, there are over 25 calls that are being made to database, even with simulator. So that were the issues. Then going into API handling and concurrency, as I mentioned, when there are a lot number of API requests, things start to fail during the when multiple threads are doing same thing. There are race conditions, and it fails on many of the things, like doing allocation on host memory or CPU, or trying to create a volume. There are also background tasks running, like different things. It is trying to fetch stats, VM stats, or doing capacity calculation for the host. So these things were slowing down the system when all the resources were maxed out. Like I talked on the topic of fault tolerance, there were intermittent failure, but then it starts to affect the whole environment. Like once a VM fails, or there is some lock in on a particular table, other operations start to fail. So things like that. Going into agent communication overhead, when thousands of agents try to connect to a management server, we were trying to have 50,000 hosts connected to a management server. There were issues when we are trying to restart management server, because it cannot handle 50,000 connection immediately. It starts to fail, and even in some cases, the whole management server process was dying. Again, the problem was also how we simulate those hypervisor hosts. So we will talk about that. Other issues, like I mentioned, resource allocation and scheduling, periodic maintenance. What if we want to stop management server? We are running multiple management server, and we want to stop one for any OS upgrades or anything. There were also considerations like tuning, what global setting values to use. There are like many weight global settings which sets the value for how much wait time should be used for different operation. What values should be used for them? What features CloudStack can support at that scale? Let's say if we are running 50,000 hosts and like 10x of that number of VMs, can we do stats functionality at that scale? Can we do something like webhooks at that scale? So things like that. Then there is also security concerns at this particular scale. So let's see now what improvements we have done to tackle all these issues. Some are there already, so let's talk about that. For this phase, like this is an ongoing project, so for this phase we have done exhaustive changes, but they are limited to persistence layer or infrastructure resources. The aim was to make CloudStack good enough that it can handle all those 50,000 hosts or 100,000 hosts, and can do all the infrastructure operations, like admin can do all sort of operations with them. For this phase, we are focused on KVM hypervisor mainly because uh, as we know, KVM has been the talk of town lately in terms of CloudStack. It is open source. And other fact is our customer was using KVM, so we wanted to focus on that. Maybe in future, because this is still an ongoing thing, and we can focus on other hypervisors as well. We also did some improvements in API and server layer, which yielded immediate gain, but weren't too focused on development or too heavy on development. Finally, we did some benchmarking and profiling to identify what tuning we can do to achieve optimal performance. Okay. So to start with, we started with this 50,000 host environment, and this is a chart of how management server behaved. In this, you can see all the utilization that it did in terms of compute resources. You can see we have set the JVM heap size to 10 GB, but it wasn't using over 4 GB. So memory wasn't scaling that well when we were without any changes or before we started this project or improvement work. Then in the second magnified view, you can see there are many red patterns which shows there is thread blocking happening. So a lot of threads waiting for either some lock or some other CPU or IO operations. So now this is after changes. We changed things like we optimized or tuned the JVM. Earlier we were using parallel GC, now we changed it to G1 GC. So memories is scaled better. You can see there is no thread blocking happening. So it gave better performance with changes. In terms of code changes and what we did in code, in database field, we used a more performant connection pooling library. We changed it to Hikari CP, which yielded in better utilization of CPU. To keep the things in more flexibility to user, we gave the option for choosing the connection pooling library through db.properties that we have. We added proper indexes to many of the tables and a lot of code improvement. Like a common structure in our code was, it was trying to list all the resources just to find the size of resources, like count of resources. So we improved those things. So after improvements, as you can see in these magnified views, earlier if it was taking calling 7,000 selects, now it comes down to 4,000. So significant improvement in database reads. So this yielded definite performance improvement. In terms of agent-server communication, after our changes, we found there was almost over 50% of improvement. This is given in milliseconds and reconnection time. We tried to run 2 management servers, and all the hosts, like 50,000 are connected to first management server, and then we killed the first, and it tried to connect to second. So that connection time reduced to almost half. Now coming back to how we mocked or simulated our KVM agents. Because TCP IP, with simulator, we couldn't simulate the TCP IP connections. So we created a new mock KVM agent plugin. It was co-developed with the customer we had. Uh, but then it wasn't just one. We even developed two. Uh, we initially started with Java-based mock agent, which used the existing agent code. But it was giving issues with memory usage. Like after maybe 20,000 hosts, we were not able to create more agents with the kind of resources I had or we were having at that time. So to make it better, we wrote a Go-based plugin from scratch. Let's see if it works. Here is, okay, this. Okay, this is a short demo how that mock KVM plugin written in Go works. On the left side, you have code which shows the configurations that need to be put in. Like it connects, in my setup, it connects to a local host, and then I give a IP seeder which will be allocated to the agents or host. And then finally, zone ID and pool ID map, which it will use. On the right side, I already have a running environment. I've just created the clusters in it, but I haven't added any hosts in the clusters. So if I, let me, yeah. In this video, I was just explaining that what all settings I have put in. Let's go slightly ahead. Yeah, as you can see, there is no host added right now. I will start my project, and it will try to create those agents. So it has I have set the agent count to 10 here in my config. It added all those 10 agents, equally distributed among 5 different clusters. So this helped us a lot in simulating how KVM agents work or how agent connection can be simulated. So this can be used by others as well. Once we polish it a little more, this will be available publicly. Now coming back to improvements, next was storage connections. Like when you restart a management server or add a new storage, it takes time to connect to all the hosts. Like if I add a zone-wide storage, in an environment which has 50,000 hosts, even with simulator or our simulated host, it would take over 7 minutes. So we worked on that and introduced a new global setting which can define the number of worker threads which can be used for doing those connections. And with just making the worker threads to 2, host connection time was brought to half, almost half there. Now, next question would be, we just set it to 2. What if we set it to more number of values? So it is not always that same gain would be seen because of how threads will be handled by the operating system. So more worker threads won't create more performance. So it should be based on what the environment looks like, what the underlying hardware is. Next is caching framework. We introduced the caching framework because not everything can be scaled or made faster. So we introduced a caffeine-based, caffeine library-based caching server framework, which kind of right now caches changes have been added to cache some of the repeated operations like accessing dynamic config keys or account roles. When like during a simple deploy VM request, CloudStack tries to fetch user role almost 3 or 4 times. So within a short span of time, it can be cached. So with this, we saw a significant improvement, like retrievals were brought down to 1/4 of the time. Like on the left side, you can see it is taking more than calling more than 19,000 times and then nearly 5,000 times. So definite improvement here. And with all the database changes that we did, even the retrieval times for each individual query was 30% lesser. So definite gain there. Now coming into VM deployments and other sort of deployments. Although the focus wasn't on deployments in this phase, and we mainly focused on the infrastructure layer, but with many of the changes within the schema layer, we found there was improvement in VM deployment as well. Now here I'm showing a graph which gives the time in seconds to deploy a VM. Environment had 50,000 hosts and there were already 25,000 VMs running on it. But this is like 46 seconds here isn't the time that might take in your environment in real production environment, because we are not trying to, we were using simulated host and we are not actually deploying anything on the storage or compute resource. So this is just the orchestration part, but this has been improved to around 18% now, which is good, but this would be improved further in when we work on further lower layers of the cloud stack. Here is a benchmarking test, like before, if it was in this graph, you can see every time 10,000 more VMs were added to the environment, and it already had 50,000 hosts running. And 50 workers were used. With workers, I mean 50 accounts were used, which were trying to deploy VMs in parallel. So you can see there is significant reduction in total time or time taken to deploy VMs here. But the concerning part here is still there is a linear increase. So we still need to work on this to make it really optimal for CloudStack. Next is tuning bit. We kind of identified a number of configurations that can be used to tune for optimal performance. These were either like database configuration, like InnoDB heap size or max connection count. They were global settings, like with respect to connected agents, it could be ping interval or VM stat time, volume stat time, things like those. Then JVM tuning, as I showed in one of the earlier graph, using G1GC, it gave better performance than using parallel GC. Then there could be OS level changes as well, like when we were trying to simulate 50,000 connected agents, there were things we needed to change in networking bits of sysctl or things like that to make it work. So idea is to come up with a recommendation documentation which can be used by CloudStack users to tune their environment. here is a benchmarking test, like I was talking about tuning, so, okay. Okay, just 1 minute more. So here is a benchmarking test we did. Often we are asked how many hosts there should be in a cluster. So this graph shows like if we put 50 hosts in a cluster, 100 hosts, 500, 5,000, and then all 5,000 hosts in 50,000 hosts in one cluster, what will be the performance of VM deployment there? Like in case of 50,000, even a single VM took over 2 hours or something. So ideally, it should be less than 500. You can see it takes much better time there. Again, another benchmarking that we did, we tried to use different number of workers. Again, with workers, I mean number of accounts parallelly trying to make API requests. So during, like on first 25 accounts were making requests to deploy 10 VMs, then 50 accounts. So I found in my test environment, at least, it was comfortable between 50 to 100 workers. But then it could depend on the underlying hardware resource that you are using. So that depends on the infrastructure. Now, with respect to the work we already done or are doing, some of the work is already available in 420. Like connection pooling library flexibility is already been added to 420, and it will be available in 420.0. Again, config key caching is there. Then larger work that we are doing with respect to infrastructure resources, that might be in 420.1. There are some UI improvements. My colleague Suresh is doing some work on management server maintenance. So that might be present in 420.1. Coming into future work, as I mentioned, it will be next would be scaling domains, accounts, VMs, and other resources, optimizing allocation and deployment logic, bringing up a comprehensive guideline for tuning parameters, efficiency of background tasks, things like that. Now coming back to the question, how many hypervisor hosts CloudStack can support? We didn't have a definite answer then, but now we can say we have tested it with 50,000. And the aim would be to test it with 100,000 hosts and 1 million or plus VMs. I hope by end of this project, we can definitely get those. That's all from me. Any questions?
No, please.
Okay. Thanks.